Hi everybody, this is Mr. Adrian, and today I'm going to talk about the modern theory of the origin of life. It's known as abiogenesis. Let's break that word apart because it is a little complicated, okay? Biogenesis means life from life. Bio, life, as in biology, and genesis, the origin. So the origin of life is just other life. Life produces life. And this is sometimes stated as the law of biogenesis. Why the law of biogenesis? Because it's derived from the cell theory, and we haven't found an exception to the cell theory. What does the cell theory say? Let's review that briefly. That the cell is the fundamental unit of life, that living organisms are composed of cells, and that cells come from pre-existing cells. Now, if organisms are composed of cells, and cells come only from pre-existing cells, that means organisms must come, because they're composed of cells, from pre-existing organisms. Okay? That's the idea of common descent that Darwin used throughout his writings. All right, so what's abiogenesis mean then? Well, if you have an A in front of a science word, often it means not. So it means not life from life. In other words, life from chemicals. Okay, that's abiogenesis, life from chemicals. This is the modern theory of the origin of life. And it's complicated, so it's going to take me a while to explain it. Okay, and I'm going to do it in three parts. The first part is going to give you some historical perspective. Okay, the second part, I'll start the modern theory, starting with Oberon and Haldane in the 1920s, bring you up to now. And then in the third part, I'll finish up the theory and talk about some exciting new discoveries and NASA's interest in the theory of abiogenesis. Okay, it's actually part of an emerging new science called astrobiology. See this guy Carl Sagan plays an important role in this new science, astrobiology. Very exciting stuff. And if there's time, I'll talk a little bit about Europa, one of the Galilean satellites. All right. So, and the habitable zone and some other good stuff like that. All right. So let's start with the idea of spontaneous generation and the observations that medieval people made about where life was coming from. Okay? Spontaneous generation. Okay? Spontaneous generation. All right, so if something says to you, wow, I feel like eating ice cream, it's kind of like a spontaneous thing, right? Let's go get some ice cream. Okay. No planning involved there. We just do it. Back in the Middle Ages, people didn't have telescopes, microscopes. They didn't have any scientific equipment. Science really hadn't started. It was the Dark Ages, medieval times, you know. The Black Death, bubonic plague. Life was short and cruel and hard. No refrigerators, okay? So anyway, people had experiences that convinced them that life could spontaneously generate from non-living things. Let me give you a couple of examples. Suppose that you were going to make dinner and you had a piece of meat, okay? But then you were distracted and you left your meat on the counter. So, a few days goes by, whatever, you're visiting friends, maybe somebody died in the family, whatever, you come back and you see maggots on your meat that you were going to have for your dinner. Where'd the maggots come from? Okay, they didn't know anything about life cycles or insects or anything like this, okay? Ooh, spontaneously generated from the meat, okay? Suppose you wanted to collect some water for bathing or whatever, or washing your dishes, cleaning. And so commonly people would take barrels out, and they'd leave barrels out, and a few weeks would go by, and it would rain intermittently, fill your barrel, and you'd go out and look at the barrel, and look down at the barrel, you'd see worms. Who put the worms in there, right? Well, nobody put the worms in there. How did they get there? Spontaneously generated from water. Don't you know that's how it works? That's life is all around you. It's everywhere, Plus there are spirits, perhaps, Spirits are in everything. Animism was a common thought or belief. There are fairies out there in the woods, right? Well, okay. Like Tinkerbell, okay. Alrighty. Another example of this was Van Helmont's little recipe for the production of mice. He actually wrote this down, and people believed it. If you take some leftovers and old rags and stuff, you put this up in the attic, voila, a few weeks, you get mice. They really believed that the rags and stuff would turn into mice, okay? So, all right, Cinderella story, kind of, pumpkins turning into chariots and stuff like that, okay? Crazy stuff, all right? But, the world was a different place at that time, and people's conceptions. I mean, think about it. People thought the earth was the center of the universe. They thought the earth did not move. Most of them believed that the earth was flat. All right? They were ignorant completely of nature and natural processes and phenomena. They didn't know why it rained. They didn't know why the wind blew. Okay? So, I know it's kind of laughable, but this idea stuck around for quite some time. Now, in the 1600s, a priest by the name of Francesco Redi, R-E-D-I, disproves the spontaneous generation of maggots from meat. All right, so I'm going to give you a moment here, and I want you to think about how you might do that. Flies buzzing around. Piece of meat. Any ideas? Okay, this is how he did it. He took 2 jars. Okay, like this, you get the picture. Put meat at the bottom of each jar. Okay? That's a variable. You'd want to control for that. He did it. He did this experiment many times with different kinds of meat. What do you think we do now? You get it? Cover one, right? Okay. So let's cover one. And he covered it with some cloth, muslin cloth, like cloth you'd wrap a bandage. Like a bandage, maybe. I'm not talking about a Band-Aid, okay? So if you got a rather large laceration, a cloth, you might wrap that wound in. Obviously, it's porous, and there are small holes in it, so it can breathe. Air can move through it, all right? So it indicated that here. This one he left open. So what are the flies going to do? They're going to be attracted to the smell of the decaying meat. They're going to be buzzing around. Okay, there we go, fly. My usual great picture. I'm never getting good at flies. There they are. And so they're buzzing around. They smell the meat. Give them some antennae. Okay, here the flies have access. Well, my picture's a little bit better here. Looks more like a dive-bombing bat or something. Anyway, lays the eggs. The maggots appear here on the meat. But here, the maggots, the eggs are laid on top of the cloth, and the maggots don't get access to the meat. Pretty straightforward. Redi concluded that, and of course he could see the eggs, and the life cycle of flies is quite short, and he observed all of this going on, okay? And it's pretty clear that meat does not spontaneously generate maggots, but come from flies. Okay. That was done in the 1600s, the mid-1600s. The next chapter in this little story is about Spallanzani. Now, Spallanzani was quite a great scientist and made many breakthroughs, one of which was in vitro fertilization. He was the first to show that that egg and sperm were needed for the production of a zygote. And he did this in a petri dish. That's what I mean by in vitro, as opposed to in vivo. In vivo means within life. He also did some experiments with insemination. In other words, he was the first reproductive biologist and made some great discoveries. Now, and this takes place in the mid-1700s, okay? So this is, I don't know, 80, 100 years later after Rady. And of course, people have made many observations by that time and were fairly convinced that a spontaneous generation of large organisms couldn't take place. And Spallanzani's experiments in reproductive biology reinforced that idea. And I'm sure that no serious person considered by the mid-1700s that large organisms could spontaneously generate, just basically, you know, like the maggot thing, right? Not happening. But what I didn't tell you was that in the late 1600s, a guy by the name Anton Von Leeuwenhoek, and I'm not going to write his name down here because I never spell it right, no, a Dutchman who lived in Delft and a haberdasher, basically a merchant, okay, and he sold, what did he sell? I don't know, cloth and stuff like that. But he was really a remarkably good scientist and sent hundreds of publications to the Royal Society on his discovery of a new world, the world of microbes. Nobody had ever seen these tiny things that he was investigating. He saw muscle fibers, for example. He would dissect animals and look at look at a variety of different tissues. He discovered protists, and he called them animalcules. So animal-like protists, paramecia, amoeba, stentor, vorticella, and many others I'm sure he observed. And he sent all of and meticulously recorded and drew very well all of these discoveries and sent them to the Royal Society. He eventually became a member, by the way. They accepted his work, but only after they sent people. They sent, you know, other scientists to verify his work, because they were quite astounded and couldn't believe that these tiny organisms existed almost everywhere. Okay, so he's often given the title the father of microbiology, the first microscopist. He made microscopes that were monocular microscopes that could magnify up to 275 times, much better than the compound microscopes at the time, which could only magnify 20, 30, or 40 times. I'm running out of time. Darn it. Oh, I just used a cuss word. You know what? That's not a really bad cuss word. So, darn. Okay, there, I did it again. Anyway, I've got a minute left, and I'm not going to be able to finish this up in this video, so I'll have to do it in the next video. I'll tell you about Spallanzani's experiments in that video, so stay tuned.